All right, folks, back at it. Okay. All right, we can have that soul shakedown party all night, but we got to do some chemistry instead. So here we go, picking up right where we left off. So that last video was a little bit longer than I wanted it to be. It was right around 45 minutes. So this one should be fairly short. In my experience with this next subject on precipitation reactions, this can be a really challenging subject for students. And a lot of it is because of dealing with these formulas. So if you recall last week before the exam in our discussion worksheet, I had to really work on breaking apart chemical formulas into their respective ions, so particularly ionic compounds. So if you're still struggling with that, that's a really good exercise to practice because for this next bit on precipitation reactions, you have to be really comfortable with breaking apart those ionic compounds into their two respective ions. Okay, so what is a precipitation reaction? So let's talk about that. Okay, so you can see here I've got potassium chromate, right? And as a reminder, when this breaks up into its respective ions, we get two potassiums, okay, and those are aqueous, plus a chromate, right? And you can see that picture right there, right? Two potassiums for each chromate. And as it turns out, chromate, the chromate ion, is kind of a yellow color in solution, okay? So we want to start using our powers of observation in chemistry, particularly in precipitation reactions, okay? So barium nitrate, right, when this thing breaks up, it becomes a barium, and remember that's 2 plus, so that means we need 2 nitrates for each barium, and you can see that right here, okay? There's the 2 nitrates and there's the 1 barium. Okay, so in the reaction, right, this is one of those double displacement reactions that you talked about in your lab. And so what's going to happen when I combine these two things, there's going to be an exchange of ions, all right? And the way we know that is because here is a picture of what happens when you can tell that this is the potassium chromate getting poured into the barium nitrate, because again, we noted that the potassium chromate is yellow. So the potassium chromate has to be there, and we're pouring it into the barium nitrate. And look, see all this cloudy stuff right there? That's what we call the precipitate. And those are the solids, okay? So in this ion exchange, what is happening is now our potassiums, so they were with the chromate, right? But now each of these potassiums are going to react with the nitrate, or the nitrate's going to react with the potassium, either way, right? We'll just say they both get together. And the other possibility is for the barium and the chromate to get together. So this is that ion exchange, that double displacement, all right? And what we have to figure out is what is the precipitate, so what is the solid, and what is in the supernatant. And in the supernatant, that are the supernatant represents the solution that's surrounding the precipitate. And that supernatant will contain the aqueous spectator ions. So how do we know which one is the solid? Our options are either barium chromate, so let's write that for our product. So our product could be, right, because you notice, like if I just said the product is potassium chromate, that means nothing happened because potassium chromate was a reactant, okay? So my possibilities are barium chromate or potassium nitrate. So one of those will represent the precipitate, which is the solid. The other will represent the ions that are in the supernatant. And we have to use what's called the famous solubility rules to figure that out, okay? So I'm not going to make you memorize these solubility rules. You will be given these on an exam, or you'll be able to reference these, but you do have to know how to use these rules, okay? So we have two separate charts. We have the soluble chart, and we have the insoluble or slightly soluble chart, okay? Soluble means it completely dissolves, completely, and don't mix that up with completely ionizes, okay? Because it does completely ionize and it completely dissolves. Slightly or insoluble means there's solid chunks left over, and those solid chunks are the precipitate, okay? So look at the rules here. So soluble, most salts with nitrate or acetate, no exceptions to the rule. And so keep in mind, when there's exceptions on the soluble chart, that means it's insoluble. And when there's exceptions on the insoluble chart, that means it's soluble, okay? So for example, when I look at this and I can see most salts with nitrate and there's no exceptions, that means if something has nitrate in it, it's going to completely dissolve, meaning it will be soluble. So what does it mean to have an exception? Well, here we go. Let's play with this one, okay? Most salts with chloride, bromide, or iodide. So for example, NaCl, sodium chloride, will always be soluble. So it will completely dissolve. But what about silver chloride? Silver chloride will be insoluble or slightly soluble. And so what that means is silver chloride will make solid precipitates. It'll make solid chunks, okay? So let's go back to this now. And we remember that when I was doing this reaction here, okay, let me see, what is my next slide after that? Yes, so let's write this out. So good practice to break this down, right? 2K plus AQ plus, I know I did this already, but this is good practice all the same, okay? And then now this breaks down into barium and 2 nitrates. So remember, this is why I had you practice that on that discussion worksheet. Get good at breaking down these formulas and recognizing the difference between coefficients and subscripts and what those things tell us, okay? So now I can see my options were either to combine potassiums and nitrates, okay, or barium and chromate. And now when I look at that solubility rule, most salts with nitrate are soluble. Okay, so what that means is when I combine these to make KNO3, it will be aqueous. There has to be 2 of them, right? Because there was 2 nitrates, 2 potassiums. I know that you want to write this K2, NO3, 2. Don't do it. Don't do that. That's not correct. It's 2 KNO3, aqueous. And then now when I look at, well, what about the barium and the chromate? I don't see any chromate. Here is chromate on the insoluble list, and I don't see barium as an exception. So that means those solid chunks that we saw had to be barium chromate, and that makes sense. So this is the precipitate. And that makes good sense because we remembered from the picture, I told you that chromate is yellow. And look, our precipitate is a yellow color. So it had to have the chromate in it. Of course, that's assuming that you knew the chromate was yellow, but if you didn't know that, now you do. And also, now we can see how our powers of observation, our ability to logically deduce what the product has to be, is also present in our deciding what is the correct product. Okay. Okay. So